Hi, in this video, we're going to take a look at the relationship between the coupon rate and the yield to maturity. So in the previous video, you should know what yield to maturity is, and it's basically the constant discount rate for any given bond. So if you're given the yield to maturity, you can just use the yield to maturity instead of the spot rates. So you don't have to discount all the cash flows year by year using the 1 year, 2 year, or how many years you have or you've been given. And this will be easier and quicker. So let's take a look at this example here, where I have a bond with face value of £1,000. The yield to maturity stays constant at 5%, and maturity is going to be 3 years. Let's take a look at the first scenario where I have a coupon rate of 3%. Let's calculate the price of such a bond. So again, I'm just discounting the future cash flow back to the present. So the first future cash flow is going to be my first coupon, which is 30, divided by 1 plus 5%. Okay, and the second one would be 30 again, divided by 1 plus 5% to the power of 2. And the final payment would be 1,030, so don't forget the face value here, divided by 1 plus 5% to the power of 3. Okay, so if you plug in the numbers to your scientific calculator, you should get the price of 945.54 pounds. Okay, so let's continue with the second scenario and see how the bond price would change if we just change the coupon rate. So in this case, I have 5% as my coupon rate. So let's just do the calculations. Okay, so step by step, we just write the calculations here. Okay, and then the final payment, 1,050 over 1 plus 5% to the power of 3. Okay, again, if you do the calculations with the calculator here, you will get a price of 1,000. Okay, so it's almost looking like a coincidence, right? So is it a coincidence that this price is exactly my face value? It is actually not. So we'll explain it later. So let's just take a look at this one, the last one here, okay, with the coupon rate of 8%. So again, let's just do the calculations here. 1 plus 5%, but now the coupon rate is 8%, so the coupons would be worth 80 here. Okay, so to the power of 2, and then the last payment, 1,080, 1 plus 5% to the power of 3. Okay, again, if you do the calculations, you will have the price of 1,081.70 pounds here. Okay, so as you can see, if I increase my coupon rate, the price of my bond should increase as well. So we have sort of the terms or the jargons to call such scenarios. So if the price is below your face value here, okay, so face value here is 1,000. If the price is below your face value, we call these bonds are priced at a discount. Okay, it's priced at a discount. And if I have the price of the bond exactly the same as my face value, then we call it priced at par. So the par value here is sometimes the same as the face value. So if the price is higher than the par value or the face value here, we call it a premium here. It's priced at a premium. Okay, and if you look closely, if I have coupon rate exactly the same as my yield to maturity, then I'm always going to get the price of the bond the same as my face value because it's priced at par. And it says that the price should be the same as the par value. And why is this? So intuitively, you can think of the compensation you have or you're getting from investing in such bond is exactly the discount rate here. So along the maturity or along the process of getting the coupon, you discount the future by 5%, which means you are required to get 5% as your compensation. And this coupon compensates you exactly that amount. So I'm fairly compensated at each in time interval where I discount the cash flows. So I'm getting a price that is exactly the same as the future value, as the face value here, because I'm well compensated here. Okay, so be careful not to confuse this with unfair pricing. So if we have the calculations here, then the numbers here are all fairly priced. If it's unfairly priced, it means they're mispricing. So we can carry out arbitrage here. So this is not unfair pricing. This is only because of the coupon structure here. We have pricing differences for different coupon rates. Okay, so if we draw this on a graph with the vertical axis, the value of the bond, and the horizontal axis, the time for this bond, then if it's priced at a premium, then value starts somewhere up and then it goes down. Okay, somewhere up there and then it goes down. So it's not a straight line, but a rather curve. Okay, if it's priced at a discount, then it goes up and then it goes to par value. Okay, if it's priced at par, then it's just going to be this straight line here. Okay, so the straight line here will be the value and it doesn't change because you're always going to be compensated at that discount rate. Okay, so this provides you a shortcut when you're trying to do calculations. So if you're given any exam questions or problem sets that has exactly the same coupon rate as your yield to maturity, then you know it's going to be priced at par. So you can sort of skip the calculations and jump to the conclusion. And it also serves as a self-checking tool. So if you have your coupon rate less than your yield to maturity, but then your bond is priced at a premium, then you know you have done something wrong. Okay, so it's very useful for you to check your answers, and also provides a shortcut if you have the coupon rate the same as the yield to maturity. I'll see you in the next video.